Can you hear me okay? Yes. How about in the back? Can you hear me back there? If you raise your hand, no one's raising their hand, so I think that means they can hear me. What do you think? So good morning. This is our talk about SRE and error budgets. So if you were looking for the talk about serverless, it just ended. How many of you were here for Martin's talk just a minute ago? All right, awesome. So we're going to build on that talk a little bit, and we're going to talk about serverless and SRE and error budgets. We're actually not going to talk about serverless at all. That was a little bit of a lie. I'd love to know, before we get started, who are you? So if you would, just raise your hand if you consider yourself a developer, or you work in development. All right, lots of developers here, that's cool. Unlike most elections, you can raise your hand, you can vote as many times as you like in this one. I forgot to set that ground rule. So how many of you are operators? So like, you don't necessarily build the systems, but you're responsible for running those systems. A few of you. Some of you like maybe do both. And how many of you are part of the business? Okay, there's a few people that consider themselves business people. I have bad news for everyone else. If you don't consider yourself a business person, maybe what you should do is quit your job and go work somewhere where you care about the business. And in fact, if you're a developer, you should care deeply about the business that you're building applications for and about those customers. If you're an operator, you should care about that as well. So let me just ask again, how many of you are part of the business? All right, look at that. Some of you already got new jobs, so I feel like my job here is done. You came to DevFestDC to find new work. You all now have new roles. Congratulations. Give yourself a round of applause. When we think about building, running, and operating applications, what we really have to think about as organizations is how do we reduce sort of the product lifecycle as we go through from concept, so we have this great idea, all the way through to bringing that idea to the market. This is the challenge that we face when we talk about things like DevOps. It's a challenge that SRE helps us solve, and it's the challenge that all of our businesses are facing every day. How do we get our ideas out to the market faster? Traditionally, there's been these walls that separate each one of our organizations as well. So if you think about the business, how do we get the business and development working together? Well, they sit in different buildings. Maybe they sit on different continents. Who knows? But we have to get those folks talking together better. And actually, Agile software development is the thing that came along and did this for us. So how many of you practice Agile software development today? And I don't care if it's a big A or a little a, just Agile. And like some of you are raising your hands like, kind of, maybe we do Agile, I don't know. But look, Agile came along and said, let's get the business and the developers working closer together. We're going to tighten up those feedback loops, help our developers understand more about what the business requirements are, which helps bring everyone closer to the customers. But we had this problem. And the problem was this. As our software development velocity started to pick up, we started building features faster and faster and faster. How many of you felt like operations could keep up? Operations suddenly became a bottleneck, right? I definitely experienced this in my own world. So I have background as a system administrator, as an operator. The development teams I was working with started building features faster and faster and faster and handing them to me and asking me to deploy them. And we simply couldn't keep up. We couldn't keep up with all of those running systems. And so this movement called DevOps was born. And the idea behind DevOps, at least initially, was that we would align development and operations, allow them to come together and work towards serving our customers. How do we build better collaboration, better automation between these walls? So, good morning. My name is Nathen Harvey. I'm a developer advocate at Google. So I work in the Google Cloud. I love to talk to people about things like DevOps and site reliability engineering. And so this morning, we're going to talk about site reliability engineering. I'm based locally here, which anyone who's based locally here knows that locally and here all deserve air quotes. So I live in Annapolis, Maryland. Who else here is from Annapolis? Who else wishes? All right, there's one in the back. What's up? You're my people. And how many of you wish we were on the water right now? Yeah, that's a better place to be, typically, than a tech conference. I mean, this is an awesome tech conference. We're going to get a lot out of the day, but we can think about being on the water, which I will do this evening. It will be amazing. The other thing that I do locally, just I'm gonna like hit pause on the thing for a second. I'm just gonna come over here and I'm gonna give you a quick advertisement. So I help organize a conference called DevOps Days DC. It's happening July 8th and 9th. So you haven't missed it yet this year, and if you come see me, I'll give you a discount code so you can come for cheaper. Okay, enough of that. Now I gotta go back to my day job. Now I'm over here as a developer advocate again for Google. So delivering software, that's really what we're here to talk about. How do we get from idea all the way through to the market? And this is where the real problem starts. Maybe not the real problem, but this is one of the problems that we need to focus on, is that our incentives simply aren't aligned. We turn to developers, and many of you in this room are developers, and we tell you, build more features. Build those features faster. The faster you ship features, the more features you build, the more money we're going to pay you. The bigger your bonus is going to be at the end of the quarter. And then we turn to the operators in the room, and that's sort of where I come from. I am, at my heart, an operator, a sysadmin. We turn to the operators in the room and we say, now your job is to keep everything stable. Make sure that nothing falls over, things are reliable, things are always working. And so we've just told our operators to say no to all of the changes that our developers are shipping over the wall. And this creates a lot of tension and friction within our organization. And we need to solve for that friction. As it turns out, I know you all are developers, and man, you know what developers love? We love writing applications, sitting on our laptop, banging out code all day long, and it's amazing. But I have bad news for you. The application that works on your laptop, nobody cares about that. Nobody cares. The applications that run in real systems that customers can interact with, those are the applications that matter. Those are the applications your business cares about. Hopefully, those are the applications that you care about. Now, as an infrastructure person and a sysadmin, I also like to remind myself that the beautiful data center with all of the handcrafted bespoke servers that I built that don't run any applications, nobody cares about that either. So basically, if we don't work together, nobody cares about our work. So we have to work together. In fact, most cost for operating systems happens after the applications have been shipped, which essentially is exactly what we want. We want our applications to spend more of their life in a production environment, deployed, serving customers, than we do sitting on our laptop. So site reliability engineering, or SRE, is a practice that Google has started. We actually, and by practice, what I mean within Google, of course, when you get to an organization the scale of Google, when you have a practice, what a practice means is you have a vice president and a bunch of people that are aligned to that practice. Now, in smaller organizations, of course, you won't have a whole vice president aligned to a singular practice. So we have a practice of using Kanbans. Do you have an organization that is the Kanban organization? Probably not. We don't at Google either, just to be clear, but we do have an SRE organization. But site reliability engineering is this idea of how do we improve not only those connections between developers and operations, but how do we ensure that our systems are stable and reliable? How do we treat this as a software problem? And it starts with this fundamental understanding and this fundamental belief that music should play during talks. No, that's a different talk. It starts with this fundamental belief that 100% reliability is the wrong target for basically everything. For basically everything. How many of you have talked to business people, product owners, and asked, how reliable should the system be? What is their answer? 100%. We want all of the reliability. We need all of the reliability. All the reliability, all the time. Everything must work. How many of you have been woken up at 2 a.m. when the pager went off? And keep your hands up for a second. How many of you who have been woken up at 2 a.m. when a pager went off, has that ever been for a thing that you didn't have to do or couldn't do anything about? Yeah, everyone's hand stays up. In fact, some new hands went up. Oh yeah, I've been woken up at 2 a.m. by my boss about something that didn't matter. You know what? That sucks. That's terrible, and we should not treat each other like that. That is inhumane treatment. We need to build humane systems. 100% reliability, though, is the wrong target. We cannot get there. We can try to get there. We can approach 100% reliability. But the investments that we need to make, both in terms of hard dollars that we're spending and in terms of the human costs to get there, are simply not worth it. Simply not worth it. Maybe some of you are building mobile applications, and you know what? Your mobile app should be available 100% of the time, right? How's that network doing? Is that network available 100% of the time? Look at that. There are things that are completely outside of your control that are going to reduce that number. So that doesn't mean we should just throw up our hands and say, well, if we can't hit 100%, we're software engineers. Everything's binary, right? So if we can't hit 100%, 0% is fine. Like that's not good either. So we have to find some way to balance these things out. And in fact, if 100% isn't the target, but what if we have this belief? The most important feature of any system is its reliability. How do you feel about that? Anyone believe in that? Believe that reliability is the most important feature? It's kind of a hard sell, isn't it? Well, I have a question for you. Some of you probably use Gmail. Yeah? Do you remember Gmail from 2010? Are you using that today? No. If you were, I would want to definitely have some one-on-one time with you after this talk. But my question is, do you prefer Gmail 2010 or Gmail 500? Which do you prefer? Look, the reliability of your system is extremely important. Your customers come to depend on the applications that you're shipping. We have to understand what our customers need and make sure that we're delivering the reliability that's there for them. What happens when your system starts to fall down in terms of reliability? What happens to your customers? They go elsewhere. You're going to lose those customers. So it may be a stretch to get everyone on board with this idea that reliability is the most important feature for your product. But I can virtually guarantee you that if you're shipping an unreliable product, you are losing customers. So some of you were in the talk earlier. Do you remember Lily? Some of you weren't in the talk, so let me tell you about Lily. Lily is this amazing veterinarian. She realized, just like Capital One did in the kickoff, in the keynote, Lily came to work one day and she said, you know what? This is not a veterinary office. This is a software company who happens to treat pets. That's me, that's Lily. I've got this theory, and it's called pet theory, and we want to provide amazing service to our customers, those small animals. So Lily's built an environmentally friendly organization. She listens to both her clients and her patients. It's pretty cool. She's like that doctor who can talk to animals. Yeah, it's awesome. And the other thing that's cool is her organization has grown. There's lots and lots of different clinics that you can go into now. And so when we talk about reliability, what sort of reliability does Lily need? What do we need within pet theory? How often does that need to be up? Well, we have to have some principled way to talk about reliability. What is the desired level of service that we should provide to our customers? And the way that we get there is through a thing called error budgets. An error budget is a way to describe what is an effective or acceptable level of unreliability within your systems. And it is a budget because just like your spending budget, it's something that can be allocated. We can allocate our budget to do various different things. So if you think about reliability, if you think about that tension between developers and operators, all of these tensions, we have to have some sort of trade-offs. If we're completely reliable, but the system never changes, we never ship new features to the customers, what's going to happen to those customers? They're going to go elsewhere. And if we have a system that's always falling down, those customers are going to go elsewhere. So clearly we have to find some balance between the two. An error budget is a way that we can balance that idea and that desire for speed and velocity with our desire for reliability. So error budgets are going to be used to capture the performance of our application. And one of the most important things about our error budget is we have to start with the customer. we have to understand who is using our applications and to what end. Why are they using our applications? Because when we set our error budget and when we set some of our metrics, we want to make sure that those metrics are telling us whether or not our customers are happy. So how many of you have ever had a customer call you up and say, hey, Nathan, look, I'm on the application right now. It seems to be working pretty well, but the CPU on the server I'm connected to is pegged at like 98%. So could you do something about that? Anyone ever had a customer call you about your CPU? No? That's weird. Anyone ever been woken up about a CPU spiking? You know, I sure have. Yeah. So where's the difference? Like, we have to care about what our customers care about. We have to understand what our customers care about. And when we set the proper targets, those targets will be an indication of whether or not our customers are happy. So it is important to wake people up in the middle of the night if our customers aren't being served. And if some human interaction can help solve that, some action by a human on our systems can solve that. But if our customers are happy, there's no need to wake anyone up. There's no need to put a human into that mix. When we think about our error budgets, this is how we want to think about them. We have 100%. We know 100% is the wrong target. So how reliable should we be? Let's say we should be 99% reliable. What's the difference between 99 and 100? 1%. All right, good. I knew there were some developers in here. You didn't have to break out the laptop. You could do that math. I believe in you. All right, so we have 1%. We are going to take that 1% of unreliability, and we haven't even defined what reliability is. Does it mean it's up? Does it mean it's fast? Who knows? We'll get to that in a minute. But we can take that 1% of unreliability. We can figure out how much time is that. So in a day, it's some number of minutes or maybe some number of seconds. And we can use that time to do things like roll out new features. We can do things for experimentation. If we fall over during that time, it's okay, as long as we come back up and meet our targets. So let's talk about some of the implementation mechanics. How do we get to defining error budgets? And it starts by looking at what are called service level objectives. So a service level objective is a performance metric that's set over some time window. So maybe we're looking across 28 days, and we say that the system should have a reliability of 99% over 28 days. Well, as we move forward in time, our 99%, we're now down to, 99.5%. So we have only 0.5% left to go. If we consume the rest of that, we need to have some consequences. What are we going to do? So what should we spend our error budget on? So let's say, or we set a goal at 99%, but what we see is that we are consistently hitting 99.9%. So we're well above our budget, or we're spending way less than our budget. So what should we do with that extra budget that we have sitting around? Well, we can use that budget to ship out new features. We can use that budget to patch the system. We can use it for planned downtime. We can run risky experiments. So there's two ways that you can think about this error budget. If you set aside a budget and you spend all of that budget, there might be some negative consequences. What we should do, because we spent all of our error budget, we should stop shipping new features, and we should focus our engineering efforts on reliability. But what happens at the end of a period if you have a bunch of your budget left over? That's an indication that you're not moving fast enough. You're not learning enough from your applications. How do we ship features faster? And we should use that error budget. We don't want our customers to get used to 99.999% if what they're happy with is 99%. Let's keep them happy for sure, but we don't need to go above and beyond. Let's use that to learn more about our customers and about our applications. So before I talk about creating an error budget, what questions can I answer for you about an error budget? Yes, Peter.
How much is sufficient?
How much is sufficient? That is a great question. And as we create our error budget, we have to figure out how much is sufficient. What is the right reliability target for us? So let's go back to pet theory. So pet theory has grown. They're really successful. They have 34 different clinics, 300 people on staff. They're serving over 50,000 clients. And they have some growing pains, though. So this is Michael. He's a client. He called 3 times yesterday to change his appointment. No one answered the phone. And Michael is unhappy. If Pet Theory is a software company, how come I can't make an appointment online? That seems pretty ridiculous, right? And our veterinarian, she wants to spend time working with patients, working with animals. But instead, she spends all of her time working with insurance companies. This is not a feasible or humane way to treat our clients or for her work. Lisa, she's our receptionist. She wasn't able to send any invoices yesterday, and the phone just kept ringing, which is obvious because no one answered Michael's call. It just kept ringing. And then we have Patrick, of course. He's in IT, and poor Patrick, they forgot to tell him that this was becoming an IT or a software organization. He showed up to work at a vet. He's like, I get to pet dogs all day. I don't have to worry about the servers. Turns out, when the website is down, we all call up Patrick, and unfortunately, Patrick just wants to pet the dogs. He doesn't even know how to get them back online, which is bad. So when we go to create an error budget, we're going to keep those people in mind. We're going to keep our customers in mind. And what we want to start with is what's called a service level indicator. And this is a quantifiable measure of service reliability. So at its most basic level, you can think about a service level indicator as a metric, as a piece of data. So as an example, let's say we're thinking about, is the application up or down? What's an HTTP status code that would tell us the application is up? 200. What's one that would tell us the application is down? 500, maybe, yeah. So if we think about what does it mean for an application to be up or down, 200 response, that's good. 500, that's not good, that's bad, right? And so we can think about our service level indicators as just that, nothing more than a metric. So we want to dig into one use case. Let's look at Michael. He's the client. We want to keep our customers happy. That's maybe where we should start our digital transformation, is with Michael. He wants to make appointments online. How do we let Michael make appointments online? So what we're going to do is define our SLIs, our service level indicators, as a percentage. And so really, I asked you a pretty simple question. Is it up or is it down? Is a 200 better than a 500? Listen, up or down is pretty complex. How many of you feel like the only thing you need in order to monitor your applications is something like pingdom hitting your homepage and looking at HTTP status codes? If I get a 200 back, website must be up. Yeah. Who in this room has a title of webmaster? Yep. That title doesn't exist anymore, right? No one is the webmaster anymore. Up is a very complicated question. Is your application up or is your application down? So for example, in Pet Theory, if I can get to the Pet Theory homepage, it feels like it's up. But my role, my job, my journey right now is to book an appointment. So I go to the homepage, it's up. I don't care about that. I click book an appointment. Now is when it matters. Do I get a 200? Yes, I can book appointments. Or do I get a 500? I can't. And so when we think about our SLIs, we actually want to pick maybe 1 or 3 or 5 user journeys. So booking an appointment online. What is the process that you go through to book an appointment online? And then let's look at all of the events that happen there. So every time you try to load the book appointment page, that counts as a valid event. And then we're going to compare those valid events with the successful events. So let's say we have 600, or I think we had said we had 50,000 customers. So let's say today, every one of our 50,000 customers decides they want to book an appointment. So I will have 50,000 requests to the booking appointment page. Those are all valid events. And then I want to look at how many of them were successful. That will be my good events, and that will give me some percentage for my SLI. Are you with me so far? All right, I see mostly heads nodding. There's 2 that are doing this, but they're in the back. It's fine. They probably can't hear me anyhow, right? All right, so when we think about our SLIs, we can't just think about availability. Not everything has to do with availability. Is it up or is it down? If you remember, as an example that Martin showed us earlier with the serverless thing with Pet Theory, they're migrating all of their back-end records into the cloud. So they hand a CVS off, a CSV off to a process, and then it puts some records into the database. That's not really a request response. That's not available up or down. What we care about there is the throughput. How long does it take from a record to get all the way through? Or its completeness. Does the record come through all the way to the database, but it's jacked up? It's not the same information as what you put in? That's a problem. So when we think about our SLIs, we can think about them in a number of different ways. It might be request response, where we would look at availability, latency, maybe even the quality of a response, the coverage. If we're talking about data processing, are we covering all of the data? What's the throughput look like? And so forth. Yes, sir?
In the case, the example that you just gave,
yes.
The 50,000 customers
yes.
accessing,
yep.
working. So is the SLI something that you track or something that you simulate?
Okay, so the question there was, for the 50,000 customers that are coming in, the SLI, is that something that you track, or is that something that you simulate? Okay, and the answer is, what you want is to actually track it, right? We don't care if our simulated customers are happy. We care if our actual customers are happy, right? Now, you can't always get all of that data that you want, so you have to have different strategies for how do you actually collect that data, right? But in the example that I gave, we should know how many people tried to load the page and how many people got a success when they tried to load the page. And so we can talk about some of the measurement strategies, right? Here's the problem with the scenario that I laid out. If I'm going to look at the HTTP status codes, what am I going to miss in terms of bad events?
Performance is slow.
I might miss the performance, so the latency. You know what else I might miss? Someone that tried to load the page but couldn't because of some network error, right? So I will never catch the people that don't even make it to my load balancer or don't even make it into my HTTP server. I don't know how many of those events I missed. So maybe over time, I can start to build in some client instrumentation so that I can do some instrumentation in the browser that says, hey, we tried to load this. Let's cache up all these errors. And then when I do have a network connection, I can send those errors off so that we can have better indication into what's failing. Now that's a little advanced, right? That's probably not the place to start, client-side instrumentation. We can start a little bit more simply. So let's talk about that thing, loading up the appointments in terms of two different types of SLIs, availability and latency. So on the availability side, how do we know if it's available? Well, the appointments page should load successfully. And how about speed? It should load quickly. But can we measure that? How do you measure success? What does quick mean? Who knows? It's all kind of relative, right? So how do we define those things? And where are failures recorded? So this is where we start talking about what are called service level objectives. So we have an indicator that says, hey, this was good or bad. We don't know what. It doesn't matter. Here's a number, like 200 or 500. You tell me which one is good, which one was bad. But how good or bad does your system need to be? How fast or slow can it be? So when we turn those into SLOs, so I want to list appointments. That's the service. My SLI type, is availability. What's my objective? My objective is that 99.95% are successful looking back over the past 28 days. So a good service level objective is going to look at one of our SLIs, one of our metrics. It's going to set an objective or a target for that metric, and it's going to be across some time window. Now, the time window is important because that time window helps define our error budget and what the consequences are. So if we're looking over 28 days, today we look back 28 days, tomorrow we're going to continue to look back. We have this rolling window. So let's say we push out a deploy that breaks everything. We pushed that out, Friday feels like the best day to push that deploy out, so we'll push that deploy out now. Everything falls over. We fall below our error budget. Now we have to have consequences. Maybe those consequences are we don't ship new features until we get back inside of our budget. Well, getting back inside of our budget is going to take a number of days as we continue to roll forward until we can start shipping new features. So at the end, your availability and latency might end up looking like this. This is what your SLO, your full SLO might look like. So the proportion of HTTP GET requests to the user's appointments page that have 200, 300, or 400 status. So at 200 status, that's good. 300, we're just redirecting them somewhere else. That's probably OK. And we're saying 4s are OK, like a 404. Do we need to wake someone up because an image didn't load? Probably not. That's probably OK. And we want to measure it at that service endpoint, so where those requests are coming in. And here it doesn't matter how we're deploying our application. It doesn't matter if this application is running on bare metal in our data center, and maybe every request comes into one single server. Or maybe we've scaled out our data center and we have a load balancer that sits in front. That load balancer is now my service endpoint. Or maybe we've gone full on into the cloud and we're running this completely serverlessly in Cloud Run. So now I just need to look at the Cloud Run stats to see what are my status codes coming out of there. But we can use this idea of an SLI and SLO in any deployment environment that we have. So our error budgets. Our error budgets are used to help define what are the consequences. When I've consumed all of my available budget, we should stop doing things that are risky. We should maybe stop shipping out new features. We should maybe focus all of our engineering efforts on things that will make the system more reliable. What makes your systems more reliable? Tests. Tests is a good thing. Like, let's say we have this appointments application and there are no tests for this application. And every time we push out a new version, what do? We roll that new version back. And then we change some things, and then we push it out again. Well, maybe we could solve that through some better testing. So let's instead of working on new features for the next couple of days, let's focus in on our tests and see if we can put more reliability into the system. Other things that will make your system more reliable include things like a better deployment pipeline, more automated deployment pipeline, maybe better monitoring. So things are starting to fall over, and we don't know that you can't make an appointment until you call us up and say, hey, I tried to book an appointment online and it didn't work. We should probably catch that before our customers, so we could invest some time there. So the idea around SRE and site reliability engineering is all about how do we get from concept all the way through to the market faster? How do we deliver software faster and safer? And we can align these trade-offs through our error budgets. And here's the thing. Most of you at the beginning told me that you were either a developer or an operator. Very few of you said that you were with the business. Imagine if we, as engineers and technical practitioners, sat down and said, this SRE thing is great. As soon as we consume all of our error budget, we're going to stop shipping new features and we're going to focus on reliability. I think we could all agree to that. But if we don't have the product owners and the business in the room in that conversation, do you think we'll be able to sell it to them after the fact? Of course not. Of course not. We as software practitioners, right, I think back on our days embracing test-driven development and embracing continuous integration. And we could very easily agree that when the build goes red, we stop and we fix it. And I know from my own experience that when the build goes red and the product owner committed to a deadline, we ship it. And that's bad. So we need to make sure that we have everyone in this conversation about what are the consequences of our error budget? What happens when we exceed or spend through all of that error budget? And let's make sure that we agree up front on what those consequences are going to be. Let's align through those error budgets. So as I mentioned, those error budgets can accommodate a bunch of new things, releasing new features. But remember, if you're not spending all of your error budget, that's an indication that you aren't moving fast enough. You could be learning more. You could be shipping things out to your customers and getting feedback sooner. So with the few minutes I have left, I just want to leave you with some reading. There are 3 books, all published by O'Reilly, about site reliability engineering. There's the initial book, the Site Reliability Engineering book, which is actually a series of essays that were all brought together that talk about site reliability engineering at Google. There's the Site Reliability Workbook that gives you good tools to take these ideas and put them into practice. And then there's Seeking SRE. Seeking SRE is a collection of, again, essays and stories from the field of people who are practicing SRE. The first two books, the Site Reliability Engineering book and the Site Reliability Workbook, are both available to read online for free at that URL at the top there, landing.google.com/SRE/books. With that, I think according to my timer up here, I have about 1 minute left. So in my final minute, what I want to do is let you know that I will be around all day. If you want to talk more about DevOps or SRE practices, please do come find me. I am not wearing a pink shirt, but if you have serverless questions, Martin is still here with his pink shirt. You can totally ask him. I'll answer some of those as well. I might even tell you the truth when I answer them. Who knows? You can test my knowledge. And with that, I will say thank you so much.
Very nice.
Thank you, sir.
Thank you. I'll
Is
take
that
this.
yours as well?
Discount code?
Discount code. Yes, I have a discount code.
You should just
Yes.
put it on the slide.
I should have put it on the slide, but that felt dirty. Instead, I just talked about it. Here, discount codes, discount codes, discount codes, discount code. Yeah?
So how did you do the captions on the slide?
Oh, yeah, the captions on the slide were, all right, I've run out of discount codes, but I have plenty more to give you. It's what is the code? DODDC. DOD, like DevOps Days, DC.
Thank you.
So there was a question as you're streaming out, and since I'm still mic'd, I'll just talk out loud. There was a question about how did I do the captions on the slides. That is an amazing new feature of Google Slides. When you present, just hit the close caption button, and it's all done with AI and ML magic of Google. And I didn't read any of them. I hope
Really accurate.
they were really good, right? They're pretty damn good. Yeah. I hope there was something funny in them also.
It tried to call you a sissy a couple times.
It tried to call me a sissy. A sissy. Oh no, sysadmin. It does correct itself also, right? Like you can see it start to do the wrong thing. Yeah.
I just had a quick question.
Yeah, sure.
What